Today's problem will be basically max profit assigning work. This is the description of the problem, but I will not go through each and every line of the description. I'll just basically explain what the overall idea of the problem is. So we have basically three arrays here. One is a difficulty array and the profit array and the worker and a worker array. So I'll explain all what do all these arrays means and what does the a question demand from us. So the first array is a difficulty array. So and the profit array. You have to see both these arrays in sync because they basically indicate this is corresponding to a particular task. So this is for zeroth task, right? So every kind of index is basically a separate task, right? And for that task, the difficulty is given by the first array and the profit is given by the second array, right? And we have some worker array which basically lists the maximum difficulty that a worker at a particular index can do, right? And the question wants us to assign jobs to all these workers, right? These are essentially the jobs. This is the one, two, three, four, five. This is the fourth index job, right? Something like that, right? So that's what the question wants from us. Let me remove this. Delete. So yeah, that's what the question wants from us. We can assign the same job to the multiple workers. That's not a problem, but the worker should have a capacity to do jobs which are lesser or equal difficulty, obviously, to what it can do. For example, this worker has a in this worker array has a number 7 written in its index, which means that the worker can do up to a max level of difficulty of 7 jobs. Can do a max difficulty level of 7 uh, for a job. So, for example, for this the first worker it can do all of the first 3 jobs, but it can't do the uh, last job and the second last job because those have difficulties 8 and 10, which are both greater than the maximum difficulty which this worker can handle, which is 7. So okay, so now this is all about the problem, and now let's slowly come to the way we are going to solve this. So the way I'm going to solve this is I'll first sort the worker array, and then I'll make pairs of this difficulty and profit and kind of arrange them in a heap with decreasing profit, because obviously we want to take the maximum profit as possible, as max profit as max profit with the so we want to take the maximum profit. So that's why we have this heap, which at a point will always have the element with the maximum profit at the top of the heap. Okay, and then why I have sorted this worker array, that will be more evident when once I start solving this problem, and I'll be explaining this while I'm doing a dry run on the problem. Okay, so okay, whether further delay, let me get started with the solution. So what we'll do is that we just look at the top element of the heap, and then compare the difficulty levels of given in the second element of the first element of the heap to the workers difficulty handling capacity. Here we can see that okay, so so we'll keep an index of I, which indicates which worker we are currently considering, right? So obviously we start with the first worker in our sorted array, and then for the first worker, I can clearly say that it can't handle this job because the maximum difficulty level which it can handle is 7, and the first job itself has a difficulty level of 10. And since it is a sorted array, and this is where the sorted array part comes in, since it is a sorted array, then we can be sure that in none of the elements after this worker, or none of the workers after this worker, can handle this, because all of the workers have a maximum difficulty level solving capacity less than this worker, right? So we can safely pop this profit kind of profit comma difficulty pair from the heap, because if a particular ith worker can't solve this, then we can be sure that in none of the coming workers will solve it. So we'll never be able to take this problem for the other workers. So they can we can pop it safely. So we'll be popping this. So let me kind of remove this kind of thing. So this item is popped. So okay, next item again for the same reason it is also popped because it is a difficulty level of 8 which is higher than 7, right? And then we come to the next item, right? Now this is a difficulty level of 30. So okay, so this worker can do this job. So so the answer is we have to return the cumulative maximum profit or the maximum profit of all the workers uh, that we can get by assigning using the constraints given in the problem. So okay, we can take this particular job for this worker. So this worker will be able to get a profit of 30. So let's put that here. So 30 plus in our cumulative profit, right? And then okay, then we'll move the pointer forward. We already solved for this. So let me move this forward. So this comes here again. This will be able to do this job because again the difficulty here and the maximum difficulty which this worker can do is the same. So it will be able to do it. So let me increase our cumulative profit pointer by one more, which is 30, and we will move the pointer forward. We'll move it forward. Uh, Sorry, this takes some time. Okay, here now again this it will not be able to do this job, so we have to pop this on the top of the stack because obviously 5 is lesser than 6, so we need to pop this. And then we are coming to here which it can do, so we'll add 20 here and move our pointer forward. All right. And for the last job again it can do this, so we'll add another 20 here, right? And now after this our pointer has run out of the array and it is at an index which is equal to the size, so the array, so basically the algorithm will stop here. So let me move the pointer. Now at this point the algorithm stops and then we reach at the end of the algorithm. So this is a I think I have this from this diagram you can clearly see why we have sorted the array and why we have like paired this difficulty and profit and arranged them in a heap in which the maximum profit is always there on the top of the heap, uh, right? uh, and then we keep on popping it and then moving forward in order to solve the problem. So now the concept is clear, and then the dry run also helped helped removing any remaining doubt. So let us look at the implementation, right? So basically what we do is that okay, we form a priority queue here, we sort the workers, right? And the priority queue is basically based on uh, descending profits, which is made sure once we uh, okay, so this is descending profits, right? And then the workers have to be also be descending workers also have to be a descending array. So this, which is given by this comparator, making the comparator greater int, so which makes the worker a descending array, which is what we want, right? And profits are by default profit work heap is by default descending. That means the it is a max heap by default, so we don't have to do anything. And also if you insert a pair, then by default the first item of the pair is used for deciding or is used for comparing, so that is also by default, so we do not have to do anything there. Then again we start with the first index of the worker index, and in our initial cumulative profit is 0 if. And then we look at and then first we look at the first item in the heap, which is the item with the maximum profit. Then if our worker is not able to handle the item, then we can be sure that none of the other workers can handle this item because the worker array is arranged in a decreasing order. So we pop this particular pair from the I mean profit and work priority queue or max heap, and then we continue. Or if worker can handle it, we basically take this profit for the worker and then move the worker index to the next worker, and then finally return the cumulative profits. Yeah, this was a pretty straightforward code once you uh, understand the solution and have gone through the dry run at least once. I hope you understood this problem and learned something from this video. I'll see you in the next video. Thank you.